Okay, so welcome back to another homework discussion video. This one we're gonna do functions. I know it's been quite late and it's long overdue. Just trying to work around the busy schedules. So first one should be an easy one. So let's see. Let's try to jog our memory. So we've been given a function f of x, which is 3x minus 2. We need to find the inverse of this function. So f of x is 3x minus 2. So you ask yourself, what does the machine do to an input uh, x? So when you look at it, if you apply your bitmass rule, you could see that first it is multiplying by 3, and then it is taken away to the x. So if I want to find the inverse of this, I'm going to do this in the reverse order, and I'm going to do exactly the opposite of these things. So if I'm doing them in the reverse, or I'm trying to undo what this machine is doing, so to undo a takeaway 2, I would have to first add 2, and then to undo a timesing by 3, we're going to have to divide by 3. So f inverse of x could be written as, if I have an input x in my f inverse function, it would add the number 2 and then divide it by 3. So f inverse of x would be equal to x plus 2 over 3. Now, part B should be easy. We're trying to find f inverse of 13, which means we're going to replace x with 13. So now we have 13 plus 2, and then divide that by 3, which should be 15 over 3, and then that should be equal to 5. That's our first question. So write the function. Think of it as a machine. What is it doing to your input? Use the bitmass rule. And now you go in the reverse order, and then you do the undo process. And then that's it. That's your inverse. Let's go on to the second question. Second one. Second one says, given that f of x equals 2x plus 1, find f of 2. So that one should be easy. F of 2 means we're going to replace x with 2. So 2x becomes 2 2's, and then plus 1. So that should be equal to 5. Part B, find f inverse of x. So f of x is 2x plus 1. So you ask yourself, what is the machine f doing to your input? So number one, it is multiplying by 2. Second thing that is doing is adding 1. So if you use your bitmass rule, or your basically use your bitmass rule, now we're going to do this in the reverse order. And then remember the example. That's like saying, when you're going to school, first you would put on your socks, then you put on your shoes, and then you tie the laces. So when you get home, you're going to do the reverse order, which means you would untie your laces, then remove your shoes, then remove the socks. So you start in the reverse order, and we're going to undo these things one by one. So to undo a plus 1, we're going to go minus 1. To undo a times 2, we're going to do division 2. So if I have f inverse as my machine, and I start with an x, first thing I'm going to undo is the plus 1, which would be a minus 1, and then I undo that times 2 with the division 2. So that's B. And then for part C, we need to find f inverse of 7. So that will be 7 minus a 1, 2. So that should be equal to 3, which seems pretty easy for question number 2. Number 3 looks a bit more challenging. Let's see. Okay, so number 3 says, given that f of x is x over 3 minus 1 and g of x is 2x minus 5, Okay, part 1 seems to be easy, so we can work out what is f of 6. That's easy, so we replace x with 6. So x over 3 becomes 6 over 3, and then take away 1, so that is 2 take away 1, which is 1. G of 3, we're going to go to the machine G, replace x with 3, so that would be 2 lots of 3, take away 5, which should also be 1. So if we add them two together, f of 6 plus g of 3 would be equal to 1 plus 1, that is 2. Work out G inverse of 7. So if you need to work out G inverse of 7, we first need to figure out what is G inverse of 6. So we're going to do the undo process. So here, the first thing that the machine does is multiply by 2. And then the second thing that it does is take away 5. So if I want to undo that process in the reverse order, if I start with an x, to undo a minus 5, we're going to do a plus 5. To undo a multiplication 2, we're going to do division 2. So we've got g inverse of x equals x plus 5 over 2, which means now I could find what is g inverse of 7, which should be equal to 7 plus 5, replacing the x with a 5. That gives us 7 plus 5 over 2, which should be 6. That's part B. For part C, we need to work out g inverse of 7. So we already know this is 6. Now we need to work out what is f inverse of 1. So if we need to work out what is f inverse of 1, first we need to work out what is f inverse of x. So if you look at the f function, the first thing that f does is it is doing a division by 3. Second thing is it is doing a takeaway 1. So if I go in the reverse order, trying to undo the process, if I start with an x, first I undo the minus 1, which is with a plus 1, and undo the division 3. Now this is where most people get it wrong. They would just write a 3 there thinking it is a multiplication by 3, but you need to remember you are multiplying the entire thing. So this is 3 lots of x plus 1, or you could also write this as 3x plus 3. So that's your f inverse of x, which means we could now work out f inverse of 1, which is 3 times 1 plus 3, and then that should be 6. So I think the answer would be 0, because we're getting 6 minus 6, and then that is 0. Okay, question number 4. Looks pretty much similar to what we've done so far. Don't know, there might be something hidden. Let's see. They've given us the inverse f inverse can be written as, oh, okay, that is where it can get a bit tricky. So this here is your f inverse. So we need to find f of 2. F of 2 seems easy, so all you've got to do is replace your x with 2 in the first one. So that would be 2 plus 5 over 2, which should be 3.5. And then f inverse means you're going to replace x with 2 in the f inverse function. So f inverse 2 would be 5 over 2 minus 1, and then that is equal to 5. So that was genuinely easy. Okay, so that looks a bit different. Oh yeah, this is the different one. Yeah, the So when we try to do a inverse function with this one, the key idea is if you look at the input, you've got your input variable both in the numerator and also in the denominator, and this is where that is your marker to identify that this is not your usual shoe, socks, laces technique. This is the other one, or the weird method where we're going to have to do a bit more of work. So I'll walk you through the process. Step number 1, we're going to say, okay, let's just write the question. F of x equals x plus 3 over x. Now, whenever we try to represent a function on a graph, the idea is the x coordinate is your input, And the y coordinate actually gives you the output or the value of the function when you plug in any number. So to give you an example, if I say the number here is -3, 1, what that tells you is if I use x as an input, if I use -3 as an input, then the output or the value for f of -3 would be equal to 1. So that is what every point on a graph of a function is trying to tell you. In other words, the value of that expression is typically represented by the y coordinate. So I could say y is equal to x plus 3 over x. What we do now is we will try to make, so now x is the subject because that kind of gives you your output. But because I'm trying to get the inverse function, we will try to make x as the subject. So now y is the subject. My aim is to get x as the subject because the inverse function emphasizes on your output. So here the star of the show is the output. I am trying to get to input being the star of the show because that is what an inverse function does. Inverse function kind of takes you back to your input. So to do this, we're going to have to do a bit of rearranging. The rearranging is going to get slightly messy. So you multiply the x. So you get xy equals x plus 3. I am trying to get to x equals something. So we're going to collect all the x terms on one side and everything which doesn't have an x on the other side. So that x becomes a minus x, and then that will be equal to 3. We're going to factor out the x, which means we're going to say x times y minus 1 equals 3, because when I expand that, that is how I get the line above. Now I need to get to x equals something, so the next best option is we're going to divide with y minus 1, divide with y minus 1, and we kind of end up getting x equals 3 over y minus 1, because these two y minus 1s then cancel off, giving you x equals 1. And now the subject or the star of the show is x, which will now be your f inverse. So your f inverse of x is equal to 3 over y minus 1. However, if you notice, my inverse function doesn't work on y, it works on x. So what I'm going to do is we're going to copy the structure of that inverse function and then use that same structure, but instead of a y, we're going to replace that with an x. So that's f inverse of x, f inverse of x equals 3 over x minus 1. It's basically having the same structure like your 3 over y minus 1, but it's just that because our machine runs on x, we're going to use the structure in terms of x as well. So this is the tricky one, or the other weird one where you have to use a bit more of work in figuring out the inverse. And the key marker is, if you notice your numerator and your denominator having the x thing on it, that is when you realize that this is slightly different or slightly difficult than your normal shoe, socks, and tying laces style function. Okay. Number 5. Oh, this looks slightly longer. Let's see. Seems to be a calculator question, but nevertheless, we'll try it without a calculator. Hopefully I don't get it wrong. Okay, so the functions g and h are such that 2x plus 5, blah, 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 h of x equals ax plus b, where a and b are constants. So h of 3 is equal to 26. What does that mean? Let's start with that idea. So h of 3 equals 26, which means if I plug in x as 3, I should be able to get an answer 26. So let's try doing that. If I plug in x as 3 into the formula that they have given us, then h of 3 would be equal to 3a, because this becomes a3 and a3 and 3a, roughly the same thing. So I get a 3a plus b, and I do know that this has to equal to 26 according to my question, because all I've done here is I've created that bridge in the middle by using the expression that was given to us in the question. So the first piece of information that we know is 3a plus b is equal to 26. Okay, second one is slightly more trickier. So it's not g of x, it's g inverse of 21, and it has something to do with h of 1. So what do we know about h of 1? We could do the same thing with h of 1. H of 1 would be equal to, plug in x as 1, that means you would get 1a, or just a, plus a b. So we've got what is h of 1. Let's go back and then try to figure out g inverse of 21. But then if you want to figure out g inverse of 21, you first need to then figure out what is g inverse of x. So let's get to g inverse of x. If you look at now, this seems to be a simple, easy one. So first thing, that's multiplying by 2. Second option, adding a 5. So when you get back home, you're going to undo this process in the reverse order. So g inverse of x would be equal to, first you need to undo, we're going in the reverse order, so undo that with a minus 5, and then undo the timesing 2 with the division 2. So we've got g inverse of x there, which means now we could do g inverse of 21, which is 21 take away 5 divide 2. That is 16 over 2, which is 8. So now we know h of 1, which was 1a plus b, is in fact equal to 8. And so we've got a second pair of equation, which is a plus b equals 8. Now we could do a simple simultaneous equation thing. So we've got the same sign here, which means we're going to subtract, subtract, subtract. So that should be 2a equals 18. A should be equal to 9. And if a is equal to 9, now I could plug that back into my equation here. So that's 9 plus b equals 8. So I know that b is equal to -1. So b is -1, a is 9. And then that is that. It is slightly tricky because you have to bring in the idea of simultaneous. You have to bring in the idea, what does h of 3 equals 26 mean? So you need to plug in x as 3 and then use that value from this expression and then connect it to your output there. Similarly, you also need to figure out what is your g inverse and then use that g inverse expression to figure out what is g inverse of 21. So if you want to pause that and then re-watch that question, I wouldn't mind, because it's slightly a bit more trickier. Okay. The next one is about composite functions. So let's try a couple of questions from composite functions. For all values of x, we've got f of x is given by that expression, g of x is given by the other expression. So we want to find f g of 5. So let's look at this piece by piece. So I'm going to break this. I'm just going to focus my energy on g of 5. We all know how to do that. So if I do that on the side, g of 5 would be equal to 5 plus 3, and that is 8. Which means inside this red box, I now get to write, I've actually found out a value of g of 5, which means this is 8, which kind of tells you now that what you're actually looking for is f of 8, because this g of 5 part has become 8, which means all you've got to do now is find f of 8. We do know how f of x works, so if you replace x with an 8, you get 8 squared, and that should be equal to 64. Now, next question is g of f and then f of g the same thing? I guess we'll find out. We know what is f of g. Now, please do not think, the most common mistake is people tend to think, oh, this is f times g. So they tend to do x squared times x plus 3 and then use, no, please, it's not a multiplication. It's a composite function. We're not doing multiplication here. It's because in algebra, whenever we see ab, it's very tempting to think of it as a times b, but unfortunately the notation works the same way, and then it's very tempting to think of that as a multiplication, but it is not a multiplication. Part B, so we need to do gf of 5. The first thing we're going to do, we're going to focus on the f of 5 part. F of 5 is easy. Replace x with the 5, so we do know that f of 5 would be equal to 5 squared, which is 25. You will get 1 mark if you do that, so although it's really easy to do that in your head, please show your workings in your test. Now we're going to do g of 25, which means that's going to be 25, replace x with 25, and then that should be equal to 28, which is your answer. So we do see that if fg of 5, we got that as 64, and then the other one is 28. So fg of 5 is not really equal to gf of 5, so you can't really think of them as the same thing, like ab and ba, so they are not really interchangeable. This one looks pretty easy, nothing much challenging there. But I do hope we will get a challenging question from this composite one. Let's see. F of 3, so that's pretty straightforward. Replace x with 3, so you get 3 plus 1, and then that is equal to 4. Find gf of 5, so that means we're doing gf, focus your attention on the f of 3 bit. F of 3, we've already figured that out, that is 4, which means in this box I now get to write the value of f of 3, which is 4. So essentially what that means is I'm doing g of 4. So I go to my g function and I replace x with 4, so I get 4 squared minus 3, so that's 16 take away 3, which is equal to 13. So yeah, that's not a bad question. Oh, this one is tricky, so I'll go a bit more slow on this one. Okay, so this one is slightly difficult because we don't have numbers there, we just have expressions. So we are doing fg of x. Again, same idea. Look at the box. You ask yourself, what is g of x? Well, we know what is g of x. G of x is 2x squared plus 3. So what I'm going to do is, I'm going to replace that with the value of g of x, because this time it's not a number, it is an expression. Then that expression is 2x squared plus 3. Okay, I'm going to put that in a bracket. That means what we're doing now is we are trying to do f of 2x squared plus 3. I hope it's okay to here. Now, you ask yourself, what does an f do to its input? It basically takes away 1. So if you think of this entire thing as your input, I should be doing that entire circle and then take away a 1. Yeah, that is what we f does, right? Whatever is your input, it takes away 1 from that. So you could think of this as, think of that as a circular giant block of something, and then the machine looks at that block and just basically takes away 1. So what's inside that block? You have 2x squared plus 3. So we do have 2x squared plus 3 minus a 1. So if you simplify that, your answer would be equal to 2x squared plus 2. And that is your answer for fg of x. Now let's do it the other way around. So let's do g of g of f of x. So as always, we're going to focus on the we're gonna work our way from right to left. So the first one would be f of x, and we do know what is the expression for f of x. F of x is x minus 1. So I'm going to replace x with x minus 1. Now you ask yourself, what does g do to its input? Well, basically it first squares that thing, multiplies it by 2, and then adds 3, right? So that's your 2x squared plus, okay? So we're going to do the same thing. Take that, we're going to square it, times that by 2, and then we're going to add 3. So what is that thing? That is your x minus 1. So we're going to do x minus 1 squared times that by 2 and then add 3. Most people miss that whole squared. You need to square that entire thing. Now whole squared would be x minus 1 times x minus 1. So that would be x squared minus a 2x plus a 1. So we're going to do 2 lots of x squared minus 2x plus 1 and then add 3. So that should be 2x squared minus a 4x plus 2 plus 3. And then that, if we simplify it, becomes 2x squared minus a 4x plus 5. And then this is the answer for gf of x. So we've got two expressions. And then we need to solve. Okay, so fg of x is 2x squared plus 2. We're setting this is equal to g of fx, and gf of x is 2x squared minus 4x plus 5. So you've got a nice little equation here. So if we try to solve them, well, we could subtract the 2x squared from both sides, and we're left with, I'm going to write this on top, 2 equals minus 4x plus 5. If we rearrange that, I would get plus 4x, take the 2 to the other side, 5 minus 2, so 4x equals 3x would be equal to 3/4 or 0.75. So whenever they ask you the word solve, please remember you need to figure out what is x, and then x would be equal to 0.75. So yeah, basically you just have to figure out what is fg of x, gf of x, and then equate them with each other. That should give you your answer. That was a tricky one. Oh, this is easy. This is not bad. Should be able to breeze through this one. Okay, so same idea. We're doing f g of 2. So first, let's focus on what is g of 2. So g of 2 would be replacing x with 2. So that gives you 2 lots of 2, take away 1. So that is 3. So that is g of 2, which is equal to 3. So that means now we're doing f of 3, and then that means you have to go back to your f function, then replace x with 3. That would be 3 squared plus 3, which is 9 add 3, so that's 12. So your answer for the first one would be 12. Part B is gf of 2. So we're going to do f of 2. We're going to go to your function f and then replace x squared with, x with 2. So that would be 2 squared plus 3, which is 4 plus 3. So that's 7. Now we're going to do g of 7. We're going to go to the g and then replace your x with 7. So that's 2 lots of 7, take away 1, which is 13. So your answer for this would be 13. That wasn't bad. Then last one is really, really difficult. Looks really, really difficult. And I think it is quite tricky. But I hope your brain is not exploded yet. If yes, you can take a break and then come back to this one. Okay, so if you are still here, f of x is 2x plus c, g of x is blah blah blah, fg is work out the value. Okay. So the only thing that we can use from here is we do know that fg of x is equal to 4x plus d. Okay, so let's try to work on that one. So if you look at the first part, which is g of x, so I could think of this as f of, and then g of x is cx plus 7. Okay, now if we look at the machine f, what does it do? Well, if you have an input, it does 2 times that input, then it adds a c. So if I think of this whole thing as my input, we're going to do 2 times that and then plus c. And then what is inside that bubble? That should be cx plus 7. So if I multiply that by 2, now remember we need to multiply everything by 2, so not just the cx. So this is going to be 2cx plus 14 plus c. Okay, and then we're going to say this is in fact equal to 4x plus d, because we know that that is the value that this is got. Now comes the tricky part. The tricky part is we're going to have to compare the coefficients of x and not x. So if you look at the x part on the left, so you have 2c equals 4. So that kind of tells you, because this is also the x variable, this is also the x variable, and because you know them two are equal, we call this method as comparing the coefficients. So you're comparing the coefficients of the same variables. So that kind of forces 2c to be equal to 4, which then makes c equal to 2. Once you know c is equal to 2, you could then say the non-x part, or the constant part of this expression, which is 14 plus 2, is plus 16. And then wouldn't that mean that plus 16 is the d on the other side? Yeah, pretty much yes, doesn't it? That tells you that d is equal to the 16 on the other side. So your answers would be c is equal to 2 and then d is equal to 16. So if you have any doubts, if you want me to re-explain any of those, you can comment or let me know in the next lesson. Hope this helps. Thank you. Bye.